Hello, everyone. Welcome to my presentation titled Geographic Variation in Propolis, Composition and Antimicrobial Properties. Propolis, a fascinating product of the honeybee Apis mellifera, varies in its composition and benefits based on where it is collected. Today, I will walk you through this variation and its implications for health in honeybee biology. Introduction. To start, let's talk about Apis mellifera, the western honeybee. This species is vital to global ecosystems and agriculture, pollinating over 75% of leading crop species. But Apis mellifera is not just a pollinator, it produces propolis, a resinous material used to protect the hive from pathogens and environmental threats. Propolis is rich in bioactive compounds like polyphenols and flavonoids, which have antimicrobial, antifungal, and antioxidant properties. Its composition, however, changes significantly based on the plants and climate in the bee's environment. This brings us to the purpose of our study, understanding how geographic variation affects the chemical composition and antimicrobial activity of propolis. Our research question is, how does the geographic origin of propolis affect its chemical composition and antimicrobial potential? Throughout this presentation, I will discuss findings from peer-reviewed studies that address that question. Let us begin with the chemical composition of propolis. According to Alver et al., 2021, the levels of bioactive compounds like polyphenols and flavonoids varied significantly by region due to differences in local flora. For example, in Angola, high levels of polyphenols, 51.5, and flavonoids, 19.3, were observed. Mali had moderate levels, while Mellifera showed the lowest. This bar chart illustrates these differences. The variations are directly tied to the flora available in these regions, which the bees rely on to produce propolis. Now let's explore the antibacterial properties of propolis. Research by Sadel et al. 2008 shows that propolis from tropical climates exhibits stronger antibacterial activity compared to temperate regions. This is especially effective against gram-positive bacteria such as Staphylococcus aureus. For instance, the minimum inhibitory concentration of tropical propolis was as low as 3.9 to 31.25, while temperate propolis had MIC values of 500 or higher. The 3D plot shows the differences in antibacterial activity by region. In addition to antibacterial effects, propolis also exhibits antifungal properties. Ozarski et al. 2022 found it effective against fungal species like Candidae albicans. Tropical and Mediterranean propolis showed higher potency thanks to compounds like caffeic acid, phenethyl ester, CAPE. This bar graph highlights the antifungal activity reported in this study. Finally, Desmirian et al. 2017 revealed how local flora and climate shape the chemical profile of propolis. Temperate climates produce propolis rich in flavonoids from poplar trees. Tropical climates generate diverse phenolic compounds. Wet climates enhance the synthesis of bioactive compounds. This table summarizes the polyphenol content by region, illustrating the impact of environmental factors. Conclusion, to summarize, geographic origin significantly influences the chemical composition and antimicrobial properties of propolis. Tropical regions yield propolis with higher antibacterial and antifungal effects due to their diverse phenolic content. These findings have implications for medicine, allowing us to tailor propolis-based therapies to specific needs, and for beekeeping by optimizing hive health based on propolis composition. The study of propolis demonstrates the intricate relationship between honeybees, their environment, and their remarkable bioactive products that they produce. References as shown.